Good morning, mathematicians. Starting off a little later today. Lazy Saturday. 336. That's the number of automorphisms of the Fano plane. Beautiful. You love to see it. Yeah, we got normal office hours today. But of course, by normal office hours, I mean we are going to continue trying to solve this problem from Milne that we were working on yesterday. And I've got no idea how to solve it. How do I make this sideboard go away? How do I make this sideboard go away? I don't know. Saturday morning, no one instant in chat. It's 9 o'clock. We should be bumping already. 10 seconds in, there should have been 4,000 people. Okay. You know, I was thinking, though, so for those of you who were following yesterday, I don't know if this approach by taking this basis of the powers of some vector is going to work. Because, like, what if the element was like I, right? We would take I squared, this, and this. Like, I guess we don't get linearly... Saturday evening, yes, I guess it depends on where you are. Saturday evening. A nice, relaxing, calm evening. Then again, actually, sorry, I'm losing my mind. Right, we were gonna choose some other B, and do that. Right, we were gonna choose some other B and do that. Okay, so it all still works out. But let's see. Okay, we wanted to choose an element of order 2, or of degree 2. Yeah. So how do we do that? Maybe we don't want to choose an arbitrary element outside of our field. Milne in shambles, yeah. Yeah. Also, I do want people to think more seriously. I was just talking to my roommate about this possible idea of us, solving a problem and actually writing a paper through live streams. Yeah, I don't know what it should be on. I don't know what it should be about, but I think it could be pretty cool. I don't know what the right thing to do would be. Yeah, I don't know what we should work on. Maybe something in I don't know, some representation theory, maybe some graph theory, I don't know. Okay. Right, I guess the question is, do we have an invertible two-dimensional thing? Good morning, William. Chomp AI. Oh, we could do that. But I feel like it would be harder for people to contribute in chat to that. Or maybe it'd be easier because you guys could like copy paste code in there. That could definitely be something. Although that wouldn't quite be the same as like writing a paper. But that could be fun. That could be fun, actually. Um, okay. So, what do we do about this problem though? A is a four-dimensional central simple K algebra. The other thing I was thinking too is we could somehow try and find idempotents and send those to some of our matrix to come up with like a matrix isomorphism. Yeah. I think there's some general theory about finding like orthogonal idempotents or something. Well, what do we? Oh, you know what? What did the double centralizer theorem tell us? Actually, what did the double centralizer theorem tell us? Okay, we're gonna open up Milne. We are gonna open up Milne. This is not a Milne live stream, but we're opening up Milne. Brouwer groups and cohomology. No, central simple algebras. You can't find a lot of papers on Chomp. Unironically, might be a good idea. Not AI, but just combinatorics or whatever. Yeah. I mean, I don't think there's a lot of paper. I think the reason there isn't a lot of papers on Chomp is because people just don't believe it's a tractable thing. And I'm inclined to agree with them. Like, what can we say? What is there to say about Chomp? It's hard. We have a non-constructive proof, and I guess what would be interesting. This would be more proof theory. Is like, I wonder if you could prove that there will never be a constructive proof. But we'd have to describe what that means, right? Because, I mean, since we know there is a winning strategy. Oh, could we prove non-constructively that there's a constructive proof? Yeah, we'd have to specify what that means, because then technically there is a constructive proof. You just list all the like possible game combinations for every board size, but we'd have to come up with some definition. I'm sure someone else already has a definition. Let V be a faithful simple A module. Okay. I guess we don't know that our algebra has a faithful simple module, do we? Maybe CSAs always do? Because I was thinking maybe we could, you know, by doing the double centralizer theorem, maybe by doing the double centralizer theorem, we could like get a different model for A, and then maybe use that to construct our Quaternion algebra. The endomorphism algebra of a simple A module is a division algebra. Makes for a nice Quanta article, how eating chocolate gave rise to a breakthrough in math. That's true. What about this one? Every simple K algebra is isomorphic to this for some division for some K algebra D. I mean, what does that mean? That either means that A itself is a division algebra, right? Like it could be M1D. Or A could be M2D. But anything bigger, if the matrix algebra had dimension anything bigger, then that's it. The dimension would be too big. It couldn't be a four-dimensional thing. So I think this is going to help us solve the problem, actually. Oh, that's not where I meant to go. I think this could help us solve the problem. I think that already gives me enough information to make a new attempt at this proof, but I'm just going to look at some of these corollaries in case something helps make our life easy. Okay. I think this could be enough, because now, if we did know that we are in this case, right? I think the question we had before was, adjoin this element A. We would need to know that that element A is invertible, so that we know that we have a field. Yeah. And I think, okay, how does that help us, though? There's some degree counting nonsense that that made our lives work out in this case, right? Well, I think we realized it can't be degree 3 just by like a divisibility argument. So it's either degree 4 or it's degree 2. Right. I think we went through this yesterday. If it was degree 4, then what? Well, no, if it's degree 4, then K adjoin A must be all of A. And why would that be wrong? Why would that be wrong? Oh, because then it's a central K algebra, right? And they would have the wrong center, right? Okay, great. Okay, so we're back on track here. Right. So we have this degree 2 extension, and but now life gets harder when choosing. Life is going to get harder choosing this other B. And the other thing is that we do want, and the other thing is we want something that squares to an element of the base field. And we want it to not be -1 or 1. Right, that was from our definition of the Quaternion algebra. So if we tried to get, how would we concoct such a thing? How do we concoct such a thing? We want something. I'm sure we can get such a thing out of here, maybe. I mean, maybe by making some change of variables. Now life gets hard. What was it all this while? Yeah, Boris, that was actually easy mode you've been on this whole time. It turns out it gets a whole lot worse. So, buckle up, Buttercup. We're deep in algebra land now. Yeah. Now I'm a little bit stuck. Again. Although, okay, so I do think we could make this change of variables. Instead of calling this a, I'm going to call it x. Sorry to keep changing that. So we imagine, so it has to satisfy some polynomial, right? It has to satisfy some polynomial like this. So can we do some like completing the squares BS to yeah, right? Because we can put every polynomial in vertex form, right? So we know that there should be like we should be able to write the polynomial like this. So this means, right. So this is going to be, so changing notation again, this is going to be our A. And this will be like our generator I. What am I drinking? I'm drinking coffee. I'm drinking it out of a mug with a skeleton. It says everything changes. And it has a skeleton with a little heart. Yeah. So, okay, great. This is fantastic. So we know that we have some operator that we're just going to call I, and we know that it squares to A. Amazing. It is poetic, yes. It is poetic. And I feel, for me, there's lore behind this coffee mug. I'll never tell you guys about it, but... Only Patreon top tier. You give me $1,000 a month, I'll tell you the lore. I don't even have a Patreon yet. Damn it! I need to make hats. I need to make a Patreon. Yeah, I don't know. I'm busy. I need to apply to jobs. That's what I need to do. Okay, I squared is equal to a. So we have this thing. Now, the question is, how do we build this second operator? I mean, I guess we just choose some element. Well, I'm glad you caught the stream as well, Sammy Zhang. Any chance I looked at the paper? Sorry, which is Sammy Zhang the same name you used to email me? I don't think I've looked at the paper. I have a bunch of papers in my inbox now, and I am thinking about making a video. I do need to also email people to ask which ones were just asking me to look at a paper and which ones wanted me to like roast it online. I mean, every mug is a personality mug. A nondescript steel flask is, that also betrays shades of your personality. Oh, yes, I see. Yes, I recognize. I do think I looked at it briefly, but not in any detail. But yeah, did you want me to review it like in a video, or were you just asking my opinion on this? What's the problem I'm doing, Padraig? We are trying to prove that every four-dimensional central simple K algebra is isomorphic to a Quaternion algebra. And so far, so I've been able to argue that there's only two cases. Either A itself is a division algebra. So essentially we're arguing that so in this case, we're trying to argue that every four-dimensional division algebra is isomorphic to a Quaternion algebra. And so following the suggestion from viewers yesterday, I have been able to argue the existence of one element of this algebra, which is non-trivial and squares to some element of the underlying base field. Now we need to take a second one. So I'm going to take some x, which lies outside of here. And I suppose for entirely similar reasons that k adjoin x over here over k will be degree 2. Right, so actually we can repeat the entire same argument and we can get some other thing j which squares to some other thing b. Anyway, I want to review it is okay. You just personally want feedback because it's your first paper and you think it needs a lot of revision. If I think it makes for a good video, go ahead. Okay. I may review it even if it doesn't make for a good video because I think it's good to just pump out videos constantly even if they suck sometimes. And sometimes the videos that I think are not very good are the ones that do the best. So that's how life goes. The only caveat is I may not be able to do it very soon because I have other things planned coming up. But, yeah. But I will try to at least email you and maybe give you some preliminary thoughts. A lot of people have emailed me, so I don't remember which paper yours is. But... certainly a number of the papers I've gotten are just, a lot of them are just nonsense. I don't know if that one was yours. I think there was one that I looked at recently that might not have been nonsense, but I was just like woefully unequipped to really give it a careful critique. Okay, well, I think this does it, right? I mean, the only thing we would need to show now, we would want that we want this, we want 1 I, j, and ij to be a k basis of A. So as long as they're linearly independent, I think we would be done. Yeah. So certainly J is not... So certainly these are linearly independent because we basically chose J to lie outside of this subspace. So that has to be true. And the only other thing to worry about now is the linear dependence of the other things. But I guess we could do something like, so if we had x plus I, y plus jz plus I, j, w equals 0, we could multiply everything by I. Oh no, but that puts this term back here. Minus jw equal to 0. Chaotic dynamics paper. Or maybe I haven't looked at it yet. Chaotic dynamics. My memory ain't great these days. Okay. Yeah, somehow we want to suppose that we have a linear combination like this, and we want to force all of the coefficients to be 0. Oh, well, I guess what we could do, we could try multiplying this by its conjugate, right? Like, I think if we multiplied this by minus I minus JZ minus IJW, then basically just from the usual Quaternion rules. Wait, do all the Quaternion generator rules automatically follow from this? I squared of something, J squared of something. Yeah, it should be. Okay, I'm not checking this carefully, but my guess is that it would work out something to like A is x squared plus, no, I don't think this is going to be helpful. And then some other thing here with W. No, I'm not so sure this is helpful. Dang, gang. Where's Leo lectures and Arad when you need them? Well, to be fair, I needed them yesterday, and they were here. They set me on this path. Now I am to finish it. Okay. Well, I think... Yeah, I'm not so sure. I am not so sure. How do we get the linear independence of these things? You only join to make puns and start listening if we do topology or K-theory. Well, this has something to do with K-theory, right? We saw at the end of yesterday, so... Come on, Boris. Find a K-theoretic interpretation of it that leads to a proof. Yeah. Well, what if we kept multiplying this? What if we kept multiplying this by I? No. Somehow I need to get rid of that J term. Damn it. Well, if this were true, I don't know. Okay. If this were true, then we know that, so I guess we can assume to the contrary that they're not all 0. And then if that's true, it would have to be the case that W is non-zero, because if it were, we would have a non-trivial combination of these three things, and we know at least that these three things are linearly independent. So, oh, thanks, Mr. L. I'm glad you enjoyed the video on group extensions. I may record the next one today, but it's not going to come out. I'm going to do, the Honest Taurus gave me credits to their website to go try learning math with AI, and so I am going to in exchange, and so I'm gonna make a video reviewing it, basically. Ooh, there's 16 people watching. Wow, what a pop-in Saturday. Look at this, 247 views. Depressing. That's a long technical video. Oh, I forgot to put in timestamps. Okay. After this, I'll go put in timestamps. Also, this is depressing. How does my Silverman interview have less than 1,000 views? Very depressing. Oh, well. I can't complain. It's a good life. I should be happy. Ooh. Oh, and we got some questions. Maybe I even made a mistake. Hell yeah. Hell yeah. I love making mistakes in the public domain. Okay, so anyways. So if that is true, then we would know that ij is actually w inverse x plus w inverse yi plus w inverse zj. Okay. Yeah, what can we do? Maybe if we try some multiplication by I business here. So now we multiply by I. We get aj is equal to w inverse xi plus a w inverse y plus w inverse zj. Ij. And now we can substitute in this crazy thing again. So we get ij is equal to w inverse xi plus a w inverse... Wait, why did I write y? Oh yeah, it is y. Y plus w inverse z times w inverse x plus w inverse yi plus w inverse zj. People should be fired from peoplehood for not enjoying the technical stuff. Good, Mr. L. Well, you are definitely going to be one of my generals when I take over and become Dictador del Mundo. I'll definitely be putting you in charge of the math gulags. The interviews are just proof of the crazy street cred. I mean, I don't know if that actually gives me street cred. Doesn't mean I did anything interesting. Just means I got to talk to interesting people. Okay, so what does this mean? Well, if we rearrange these terms, these are all in terms of I and j. So now we know that all of these coefficients have to be 0, right? So first we take the constant term. So we know that a w inverse y plus w inverse c w inverse x has to be 0. So I think that's all of the constant terms. Then we also know that w inverse x plus w inverse z w inverse y is equal to 0. And finally, a or minus a plus w inverse c w inverse z is equal to 0. Okay. Lord, does this actually help us? I mean, we can multiply through the top by w inverse to get a y plus z x w inverse is equal to 0. X plus z y w inverse is equal to 0. And minus a w plus z squared w inverse is equal to 0. Okay. Now I'm losing faith in this approach. Maybe if we kept going? No, I feel like that just makes these expressions worse. Dang. I thought that was a neat idea. I thought that was going to help us. Hmm. Surely it must, though, right? Surely this has to be the way. This has to be the way. I mean, maybe if I simplify notation, let me call it x plus yi plus zj. This has to be the way, right? I'm just writing out the same thing again. Multiplying by I plus zij. Yeah. Where does one go from here? Where does one go from here? I mean, well, what else could we try? So we could try rearranging the second equation, so that this becomes z inverse a. Wait a second. Let me not do too much algebra in my head. So let's go. Zij is equal to minus ya minus xi plus aj. Right, I've moved those things over, and then I'll divide through by z inverse. So minus ya z inverse minus z inverse xi plus a z inverse j. And now, because I know that these things are linear independent and they're a basis for their span, I should be able to compare these coefficients, right? So x should be minus ya z inverse, y should be minus z inverse x, and z. There's no way that this is the way that Milne intended to solve this problem. I'm sure there's a much slicker and nice solution. But now we have these equations. Okay. So what? Well, this implies that z squared is equal to a. So that's interesting. That's interesting. That's very interesting. We also get zy is minus x. So that could be interesting if we try to multiply these elements together. And zx is minus ya. I mean, these are all things that are true in fields. So what does this mean? I mean, this means that our element A of the field would have to be a square. It would have to be a square. So but okay. So let me take this equation and multiply both sides. We get z squared y is minus xz. So z squared is a, so this is ay, but xz is minus ya, so this becomes ya. Oh, we just went in a circle. Okay. Ah! Okay. Well, this is embarrassing. Oh, I should have plugged in my laptop. Okay, well, what else is there to do? We could try. We could put a pin in this. We're very close to solving case number one, right? Maybe some clever viewer will see the way to finish this proof. We could think a little bit about. The second case. Actually, I think the second case is easy, right? Because if the division algebra D itself as a K algebra, it has to have dimension 1, right? Otherwise, I'm pretty sure it'd have to have dimension 1. Otherwise, this thing is too big. And so in that case, it is just straight up. You're losing street cred by the second. Oh, Boris, no. Hey, I'm solving the second case right now. It just has to be this, and then that's definitely this is definitely a quaternion algebra, right? Just take the what do we take as our basis? Probably just the elementary matrices, right? So well, we want one of these to be the identity matrix, I guess, because that's like our one. I'm tempted to say that we take the other two elementary matrices, but their product is 0. We want their product to be the third linearly independent thing. So I don't know. What if we took, what's the product of these two guys? That is 2, 1, 1, 1. And is that going to be, oh wait, but what are the squares of these? We want matrices that square to, so I guess we want one of them to be this. One of them could be this, because that squares to 0. Or sorry, squares to the identity. And I guess the other one could be this, because that'll also square to the identity. Right? No. That does not. No, that squares... but that squares to -1, which is still fine. It's a scalar of the identity. Right. And these matrices should be linearly independent, right? Yeah. Do we really need to check it? I mean, we should check it, I guess. We should check it. So what if we add A, B plus C, B minus C, A equal to 0? Well, then, of course, A would have to be equal to 0. Right, and then because B plus C and B minus C are both equal to 0, they're all 0. Yeah, okay, so great. So we have solved the problem in the second case. We're just down to this one final case of trying to understand why IJ has to be independent from the other things. Okay. Well, I mean, it sucks to give up here. Not giving up forever, just giving up for today and coming back tomorrow. But I think that's where I am going to leave it for today. So thanks everyone for joining me. I'll have it by tomorrow. I won't be working on this problem in the meantime consciously, but the unconscious mind, maybe it will come to me in my dreams tonight, and I'll tell you the answer tomorrow. So I'll see you then. QED. Oh wait, I just saw a question. Let me see it. Last time I was on the stream, you started your Proust class, and now you're happy to say you survived it. Hell yeah. And yet you claim to not be John Cena, and you survived a Proust class? Unlikely. Doubt it. The Proust or trash videos were helpful. Okay, awesome, great. Well, feel free to submit some trash proofs that you may help others. Yeah. Okay. Goodbye for real now.